أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Class 11 Physics Class 11 Physics Our, we are discussing projectile motion. We are discussing projectile motion. Our today's topic is horizontal range of projectile motion. Horizontal range of projectile motion. We know that it is our projectile within it is moving within the velocity u. We have distributed this u is already into two components, u sine theta and u cos theta along x-axis. It is along y-axis. Okay. We have taken sometimes point P here with x, y coordinates. It is maximum height. We know that from this point to this point, from point of when we can see the point of projection to the point of hitting to the ground. This is the distance covered by the projectile. The horizontal distance covered by the projectile is the horizontal range of the projectile. The distance covered by the projectile, the horizontal distance, the horizontal distance covered by the projectile from the point of projection to the point of hitting to the ground is called the horizontal range. So we can see this is our horizontal range, this x, or we show it or sometimes horizontal range. Okay, we know that this is our trajectory, this is our this is our projectile motion. This path is our trajectory. Path followed by the projectile is called trajectory. Okay, so we are what we are discussing. We are discussing here horizontal range of a project. For horizontal motion, we have this is our horizontal motion x. It is covered in the time t, and we know its velocity is u cos theta. So we can see the x is equal to u cos theta into t. This is our x. R. We can take this x is equal to r. We can show horizontal range. R is equal to u cos of theta into t. U cos of theta into t. It is our equation for horizontal range. But we can use this instead of t. This t. What is our t? T is the time of flight. Yesterday we have take the equation for time of flight. R is equal to u cos of theta into t. Instead of t, we can use the value of t. That is twice u sine of theta divided by g. Yesterday we have derived this value. Twice u sine of theta was time of flight. Okay, we can use this. It may be 2 u into u will u square. It may be sine of theta into cos of theta divided by g. Okay, it is our what? It's our equation for horizontal range. Okay, we know that sine theta into cos theta, is equal to sine of 2 theta from 11th class trigonometry. Okay, r is equal to twice u square sine theta cos theta is equal to sine of 2 theta divided by this g. This is our equation for horizontal range. We can find if theta is given, and its initial velocity is given, this u is given, we can find the horizontal range. Always we can find time of flight. If u and theta is given, we can find time. Or we can find horizontal range. If the problem is asked in the examination, before that u must be given and theta must be given. Theta is this theta. This is the angle of projection throwing this projectile. When would be the maximum horizontal range? When would be this maximum? When would it cover a maximum distance? For example, if we throw a projectile here, it may cover a maximum distance. It may go a long distance. It may go long. It may cover a long distance, a long projectile before hitting the ground. When it would be, maximum. So we can see that maximum horizontal range. Maximum horizontal range. When would be maximum R max? When would be R max? R max would be only if this sine of 2 theta, if the value of the sine of 2 theta, if sine 2 theta would be 1, sine 2 theta would be 1, sine 1 would be the sine 2 theta 1. If sine 2 theta would be sine of 2 theta would be 1, that means it may be equal to sine of pi by 2. Sine of 90 degrees is equal to 1. So we can say sine 2 theta is equal to sine of pi by 2. The sine and sine we cancel, that means 2 theta is equal to pi by 2. Or theta would be is equal to pi by 2 divided by 2, it will be pi by 4. That means theta would be pi by 4. If this theta is equal to pi by 4, then there would be horizontal range would be maximum. If theta is pi by 4, horizontal range will be maximum. That means theta should be of the angle of how much degree? 45 degree. If we throw a stone or throw a ball, throw a bullet, or throw any sort of projectile in, it may if it makes an angle of 45 degree with the projection point, with the starting point, then it may cover a maximum horizontal range. If we increase its value, it may go upward. It may cover upward distance. It may cover vertical distance more, but it may not contain. It may not cover this horizontal. It may cover if and only if we throw it with what angle? Angle of 45 degree. Theta should be equal to 45. 2 theta should be equal to that pi by 2. Okay. Now, what would be R max? R max would be equal to, then we can take this we have u square sine of 2 theta divided by g. Instead of sine of 2 theta it is 1, then R max would be equal to u square by g. We can find maximum distance only if there is only velocity. We can find this R max means maximum horizontal range. Maximum horizontal range. If only velocity is given, we can square that and divide by g. G would be 9.8 meter per second square. We can find out maximum horizontal range. Okay, it was all about the horizontal range. Now, there are two angles of projection for the same horizontal range. Two angles of projection. Two angles of projection for same horizontal range. Okay. Let first horizontal range would be R1 is equal to u square sine of 2 theta divided by g, which we have discussed earlier. For the second angle, let the second angle may be angle of projection may be 90 degree minus theta. 90 degree minus theta. Instead of theta, we can write 90 degree minus theta. Then R2 would be u square sine of 2 into 90 degree minus theta divided by g. That would be equal to u square sine of 2 into 90 is 180 degree minus 2 into theta is minus 2 theta divided by g. That will be again equal to, then R2 would be again equal to u square sine 180 degree minus 2 theta is equal to sine of 2 theta divided by g. It is again this R2 is R. What is R1? R1 is u square sine of 2 theta by g, and R2 is u square sine of 2 theta by g. So we can say R1 is equal to R2. The same maximum range when when we have a different angle. But we must remember what is their different angle. Their different angle if one is when it is equal to theta, and another is when it is equal to 90 minus theta. That means we have taken theta 45 degree. Also, when we take here 90 minus theta, that may be 90 minus 45 degree. That is also a 45 degree. So we can use these two terms when the theta is equal to when we have a same horizontal range, when the angle of projection is either theta, either it is 90 minus theta, we get the same answer in both the cases. We get the same horizontal range. It may be asked in examinations as objective when would be the same horizontal range. What would be the theta? Theta will be at that time the theta would be first it is theta, and secondly it may be 90 minus theta. If theta would be pi by 4, here also it will be theta would be pi by 4. 90 minus pi by 4, that is also a pi by 4. 90 minus pi by 4 is 45 degrees. 90 minus 45 degrees also a 45 degree. Add these two cases, the horizontal range may be same. But we must remember horizontal range is equal to u square sine of 2 theta by g. Maximum horizontal range is r is equal to u square by g only. At that time, sine of 2 theta is equal to 1. Thanks. Tomorrow we will take ahead of this.